Take a look at these glasses. Why is water forming on the outside of these glasses? Take a look. You can see right here, you can see there's water forming on the outside of the glass. This, you can see it's even dripping down the sides of the glass. Why is that happening? You know why that's happening? Go ahead, you can tell me. Well, that water is called dew. This is condensation onto the surface of an object that has dropped below the dew point temperature. The critical thing here is that the object itself, in the case of the pictures you just saw, the glass, the object is below the dew point temperature. The object then cools the air that it is in contact with. So that glass is cold because it has something cold in it. Then the air that's touching it also drops down in temperature because it becomes like the temperature of the glass. And the air takes on the characteristics of whatever it's in contact with. As air temperature drops, remember rule number 2, relative humidity rises. So by pouring that cold soda with the ice in it into the glass, that cold soda and the ice then cooled down the temperature of the glass, which then turned around and cooled down the air that was touching the glass. And as that air temperature dropped, relative humidity rose, the air temperature went down, 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 reached the dew point temperature. At that point, the air is saturated, the relative humidity is 100%, and water must come out. And water always must come out onto something. You're going to watch a video today for the lab of me doing something like this in the classroom at Santa Ana College. And then you're going to answer some questions about it too. This contraption is called a sling psychrometer. Sling because you sling it around. Again, you're going to watch 2 videos on this thing and me doing that thing, which is slinging the psychrometer. This is what we use to get relative humidity. Notice that there are 2 thermometers on the sling psychrometer. One has some cotton wrapped around it. We call that the wet bulb because what you do is you dip the wet bulb with the cotton into some water, just the part where the cotton's at. The other one is called the dry bulb. The dry bulb, you don't want to get wet. The dry bulb, you want to stay dry. And when you sling this thing around, what's going to happen is this. The dry bulb is going to give you air temperature. The wet bulb is going to give you something that's called the wet bulb depression because water is going to evaporate off of that cotton cloth. Evaporation is a cooling process that will drop the temperature of the thermometer that we call the wet bulb. Now, this is another version of a sling psychrometer, but this one is in Celsius. And you can see the wet bulb with the cotton on it, and then you can see the dry bulb that has no cotton on it. You dip the wet bulb into the water, just the cotton, and then you sling this thing around. The dry bulb gives you air temperature, in this case in Celsius, and then the wet bulb is going to give you the depression, which is going to be a lower temperature than the dry bulb because water is evaporating off, which cools down that thermometer's temperature. And then, of course, in order to do this for Fahrenheit, you would have to convert this from Celsius to Fahrenheit, which you are going to do. Let's assume we did it, and we found that the dry bulb was 75 degrees and the wet bulb was 50 degrees. The way we find the wet bulb depression is just simply this. We take the dry bulb temperature, 75, subtract the wet bulb temperature, 50, and we get 25. 25 degrees is the wet bulb depression. If you look at the lab, you're going to notice this. Here's another table, another one. And in fact, on the same page, there's another one that looks just like it. This one tells you relative humidity psychrometric tables down there at the bottom. If you look along the left-hand side, you can see air temperature. This is in 5-degree increments. And you can see depression of the wet bulb. This is in 1-degree increments. Now, we just determined that for our example, the air temperature, the dry bulb, was 75 degrees. The wet bulb was 50 degrees. 75 minus 50 is 25. That makes the depression of the wet bulb 25 degrees. You can see that I have a red arrow pointing at 75 degrees, the air temperature, which again came from the dry bulb. And then you can see I have another arrow pointing at 25 degrees up at the top for the depression of the wet bulb. The 25 degrees comes from the 75 dry bulb minus 50 wet bulb equals 25. Guess how we're going to find out the relative humidity? Correct. We just put these two lines together, the 75 going across, the 25 going down. Where they meet, 9, which means the relative humidity under those circumstances would be 9%, really dry air. Today, with the application of the sling psychrometer video from Santa Ana College, you are going to fill in the information you see there. So you're going to tell me what the dry bulb temperature was indoors, what the wet bulb temperature was indoors, what the depression of the wet bulb is. In other words, you take dry bulb minus wet bulb, and then you're going to look at another table and determine relative humidity. It's a much more complicated table. So complicated I can't even put it on here, but you'll see it because it's on the lab. And then the same thing for outside. So you're going to watch those two videos. I'm inside and I'm outside using a sling psychrometer and giving you the information. And then you just fill it in.